Now that we have our software installed, our exercises in place, and we're going through this PowerPoint, I'm going to introduce you a little bit to the processes and how we're going to run this today. Each section or each exercise, as we're working through the hands-on test drive, I will cover a PowerPoint kind of describing the topics that will be covered in each phase or each exercise. My coworker will be then taking over the controls to walk you through the exercises themselves. Some of the exercises may contain multiple videos or will have a single video. In either case, the video name will be at the bottom of the PowerPoint for you to follow for those exercises. Our first exercise that we're going to be starting with is the part modeling environment. Some of the topics to be covered in this first exercise is working with an assembly file and exploring the user interface and the viewing tools that we will need when working with Autodesk Inventor. In this case, we're going to review some engineering notes so we can understand what types of things need to change or some types of things we need to create as we're working through this exercise. We're going to go through and we're going to reuse AutoCAD 2D drawing data, which most companies typically have as legacy data, and turn that into 3D. No one makes that transition better than Autodesk. We're going to work with some simple part features. One example would be the extrude command. And additionally, we'll add some other sketches and place additional features into our design. Without further ado, I'd like to hand this over to my coworker and let him take you through the part modeling exercises.
In this exercise, we will be creating this link rod component, which consists of three features: my main or base extrusion, the tapped hole at the top, and also a mirror feature which mirrors that hole to the other side. The mirror inside Inventor acts pretty much the same as your mirror command inside of AutoCAD. So to start off, we will select a template. So I'm going to switch over to my metric templates and select the standard millimeter part template file. Once selected, I have a new part file created. I am inside sketch mode. I have my origin or the center of my part already established, and I have all my sketching tools towards the top. I'll first start off by drawing a circle, and my center point of my circle will be right at the origin point of my part. This will center my part along my origin. It's always good practice to always fully constrain your sketches and also to constrain them to your origin. I will first by creating a dimension, so this will be a diameter dimension. Before I place my dimension, I can right click and switch over to a radius dimension if needed. I will keep my diameter dimension. And also I want to verify that my edit dimension box is checked. With that selected, whenever I place a dimension, I can then immediately apply a value to that dimension in my edit dimension dialog. So I'll accept that. I now have my 12 millimeter diameter dimension established in my circle, which fully constrains my sketch. So therefore, I can now finish my sketch and extrude it or give it depth. So I will select the extrude tool, give it a value of 50 millimeters, and because this is my base feature, I will switch it over to the midplane, which will fully center my part around my origin point. Select my home key to get back to my original view, and there is my first feature. I am now ready to place a tapped hole at the top of my plane here. I'm going to switch over my placement to concentric to fully center my tapped hole along this surface here. So it will be placed on that top plane, and it will be centered along that circular reference. Apply my depth of my hole, so 20 millimeters, and my diameter, which will be 8. And because this is a tapped hole, I have my option to create a tapped hole here, switch over my thread type to a metric profile, and allow my designation to be an M8 by 1.25. I also have an option to have a fully tapped hole, but for this instance I'm just going to apply a depth of 17 millimeters to my tap. and then click OK. Let's do our rotate tool, and we can see the tapped hole by orbiting our part. And also by right clicking, I can get to my home view also. Now I'm done placing my second feature, which is my hole. I want that same hole now to be also on this other side of my rod assembly. So let's go back to the home view, and I'm going to select the mirror command. The feature that I'll be mirroring will be my tapped hole. I can either select it in my graphics area right here, or I can select it in my browser. Sometimes it'll be easier to select it in the browser. My mirror plane will be the midpoint of my part, and because I created my first base extrusion along the midplane, I can utilize the XY plane that was already created in my template as my mirror plane. And then click OK. Do the free orbit, and you can see the tapped hole on both ends. If I expand out my mirror, you'll see that the feature that has been mirrored is the tapped hole. With this complete, we can now save this part file so that it can be inserted into a future assembly in our exercises. I will call this a link rod.